Have you ever closed your eyes in a quiet, dark room and wondered if the world around you still exists in exactly the same way when you are not looking at it? It sounds like a philosophical riddle, a gentle question posed by ancient thinkers sitting under a vast, star-filled sky. We walk through our daily lives, assuming that the physical world is solid, permanent, and entirely independent of our gaze. The chair you are resting on, the walls surrounding you, the quiet earth beneath your feet. Surely these things remain exactly as they are, whether you pay attention to them or not. We feel a profound sense of intellectual safety in this assumption. It grounds us. But what if I told you that the most rigorous, tested, and precise branch of modern science suggests something entirely different? What if the very act of observation is what pulls reality out of an infinite haze of possibilities and forces it to take a definite shape? This is not dramatic storytelling. This is quantum mechanics. And at the very heart of this science lies a mystery so profound, so deeply unsettling, that some of the greatest minds in physics have spent their lives trying to find a way around it, often hiding the most disturbing implications behind complex mathematics. Welcome to a journey into the quantum realm, a journey that will challenge everything you thought you knew about the cosmos and your place within it. Hello, my friends. Before we dive deeper into this vast cosmic mystery, I want to take a brief moment to introduce myself. I am Theodore, the researcher. I have noticed that 71% of the people who watch our videos and join us on these contemplative journeys have not subscribed yet. If you find peace and wonder in exploring the profound mysteries of our universe, please consider subscribing to the channel. It helps us incredibly, and it ensures that we can continue to wander through this beautiful, endless universe together as a community of explorers. Now, let us return to the quiet silence of the quantum mystery and the strange nature of reality. To truly understand this paradox, we must travel back in time to the early years of the 20th century, an ancient era by the standards of modern science, when the foundational pillars of physics were being shaken to their core. For centuries, scientists believed that the universe operated like a giant, predictable clockwork machine. If you knew the starting position of every gear and the force applied to it, you could perfectly predict the future. This was a comforting thought, a gentle reassurance that the universe made logical sense. But as our instruments grew sharper and our curiosity pushed us to look closer, we began to peer into the microscopic world of atoms and subatomic particles. We expected to find tiny, solid spheres bouncing off one another in predictable paths. Instead, we found a realm of shimmering probability, a place where the normal rules of physics dissolve into a strange, beautiful haze. The turning point came with something called the double-slit experiment, a deceptively simple test that has become the most famous demonstration of quantum weirdness. Imagine a solid barrier with two narrow vertical slits cut into it. Behind this barrier is a blank screen, waiting to record whatever passes through the slits. If you were to fire tiny solid objects, like grains of sand, at the barrier, you would expect to see two distinct bands of sand accumulate on the screen behind the slits. That is simply how physical matter behaves in our everyday experience. But when physicists fired individual electrons, the tiny particles that orbit the nucleus of an atom, at the barrier, something entirely counterintuitive happened. Even though the electrons were fired one by one with absolute precision, they did not form two bands on the screen. Over time, as hundreds and thousands of electrons hit the back screen, a complex pattern emerged. It was an interference pattern, a series of alternating bright and dark stripes That is the unmistakable signature of waves overlapping and crashing into each other. It was as if each individual electron was not a solid particle at all, but a gentle ripple spreading out across the silence of space, passing through both slits simultaneously, interfering with itself, and only deciding where to land at the very last possible microsecond. This alone was enough to generate a profound sense of awe and confusion among the scientific community. How could a single, indivisible piece of matter act like a wave of infinite possibilities? But the true mystery, the disturbing paradox that still haunts physicists today, had not yet revealed itself. Driven by a deep existential curiosity, scientists decided to place a tiny detector right next to the slits to see exactly which slit each electron was passing through. They wanted to peek behind the curtain of reality to observe the particle in the act of choosing its path. They set up the experiment again, fired the electrons one by one, and turned on the detector. The detector quietly registered each electron, confirming that it went through either the left slit or the right slit, acting exactly like a solid, well-behaved particle. But when the physicists looked at the screen at the back, the beautiful, complex wave pattern had completely vanished. In its place were two simple, boring bands of impacts, exactly what you would expect from grains of sand. The mere act of placing a detector there, the simple act of observing the electrons, had fundamentally changed their behavior. When they were not being watched, they behaved like infinite waves of possibility. The moment they were observed, they collapsed into definite physical particles with a single, specific location. It was as if the universe knew it was being watched, and immediately changed its behavior to hide its true, wavy nature. This is the observer effect, and it is the quiet, hidden engine that drives the most profound mysteries of our existence. It suggests a reality that is vastly different from the one we experience every day. In the quantum realm, before an object is observed, it does not have a definite state. It exists in a superposition, a ghostly state of being everywhere and nowhere, doing everything and nothing, all at the same time. It is only when an observation is made that this vast cloud of possibilities collapses into a single, concrete reality. The great physicist Werner Heisenberg famously realized that the atoms or elementary particles themselves are not real in the same way that everyday objects are real. They form a world of potentialities or possibilities, rather than one of things or facts. This realization forces us to ask a question that bridges the gap between hard science and deep philosophy. What exactly constitutes an observer? Does it have to be a conscious human being? Does a mechanical detector count? What about a mouse, or a single-celled organism, or a tiny grain of dust floating through the eternal silence of the void? For decades, physicists have debated this quietly in the halls of universities and in the sterile environments of laboratories. Some argue that an observer is simply any macroscopic system that interacts with a quantum system, forcing it to lose its delicate quantum coherence. According to this view, the universe is constantly observing itself, collapsing its own wave functions through endless, mindless interactions. A photon of ancient light from a distant galaxy, traveling for billions of years through the quiet, vast emptiness of space, collapses into a definite state the moment it strikes the dusty surface of a dead asteroid. But there is another school of thought, a much more unsettling interpretation that some physicists find profoundly disturbing. This theory suggests that consciousness itself is the fundamental ingredient required to collapse the wave function. It posits that the universe remains in a state of suspended animation, a shimmering web of infinite probabilities, until a conscious mind perceives it. Consider the cosmic scale of this idea. When the magnificent space telescopes operated by NASA and the European Space Agency capture ancient light that has been journeying across the cosmos for 13 billion years, we are seeing the universe as it was in its infancy. But if the consciousness-driven observer effect is true, then that ancient light and the primordial galaxies that emitted it existed only as a hazy probability wave for 13 billion years. It was only when a conscious human eye finally looked at the digital screen that the wave function collapsed, retroactively forcing that ancient galaxy to take a definite physical shape billions of years in the past. This implies a universe where space and time are intertwined with the presence of a mind. We are the cosmos observing itself, waking up from a 13 billion year slumber. This thought brings a strange, peaceful humility. It transforms our ignorance into a profound motivation to learn. But it also raises an even larger question. If conscious observation is required to make reality solid, then who was observing the universe before human beings evolved? We will continue to unravel this mystery together, stepping deeper into the infinite silence of the unknown. If conscious observation is required to make reality solid, then who or what was observing the universe before human beings evolved? This is the paradox that forces us to look backward through the vast corridors of time, beyond the birth of our solar system, beyond the formation of the Milky Way, all the way back to the very dawn of creation. In its earliest moments, approximately 13,800,000,000 years ago, the cosmos was a tiny, unimaginably hot, and infinitely dense point of energy. It was a realm where the laws of classical physics had not yet been established, a primordial furnace governed entirely by the strange, probabilistic rules of quantum mechanics. As the universe expanded and cooled, it transitioned from a quantum state to a classical one, eventually forming the protons, neutrons, and electrons that would build the first stars. But if we follow the logic of the consciousness-driven observer effect to its ultimate conclusion, we are faced with a profound mystery. If reality requires an observer to collapse its wave function from a state of infinite possibilities into a single, definite history, how did the early universe become real when there was no one there to look at it? This question leads us to one of the most brilliant and unconventional minds in the history of physics, John Archibald Wheeler. Wheeler was a titan of 20th century science, a colleague of Albert Einstein and Niels Bohr, and the man who popularized the term black hole. But in his later years, Wheeler turned his formidable intellect toward the deepest mysteries of quantum mechanics, and he proposed an idea so radical, so profoundly disturbing to traditional scientific materialism that many of his peers struggled to accept it. He called it the participatory anthropic principle. Wheeler suggested that the universe is a participatory mechanism, a self-excited circuit, where the act of observation in the present actually reaches back through the quiet vastness of time to create the physical reality of the past. To illustrate this concept, he devised a thought experiment stretched across a cosmic scale. Imagine a distant quasar, a brilliantly glowing galactic core powered by a supermassive black hole sitting billions of light years away in the ancient, dark depths of the cosmos. Between this quasar and Earth lies a massive galaxy. The immense gravity of this intermediate galaxy acts as a cosmic lens, warping the fabric of space-time around it. When light from the distant quasar travels toward Earth, it encounters this gravitational lens and is forced to split, taking two different paths around the galaxy before arriving at our telescopes. This setup perfectly mimics the two slits in a quantum experiment, but on a scale of billions of light years. The light from the quasar can travel along the left path or the right path. According to quantum mechanics, until the light is observed, it travels along both paths simultaneously as a wave of probability. Wheeler asked a simple but devastating question. What happens if we delay our choice of how to observe the light until the very last moment, just before it enters our telescopes here on Earth? We can choose to set up our telescope to act like a screen, recording an interference pattern which proves the light traveled as a wave along both paths for billions of years. Or we can choose to set up our telescope with two distinct detectors aimed at the left and right sides of the intervening galaxy, forcing the light to reveal exactly which path it took, acting as a solid particle. Here is the incredible part, a fact that has been verified by modern experiments in laboratories around the world. The choice we make today, right here on Earth, determines the behavior of the light billions of years ago. If we choose to measure the light as a wave today, the universe ensures that the light traveled as a wave for its entire ancient journey. If we choose to measure it as a particle today, the universe retroactively ensures that it traveled as a solid particle since it left the quasar. Our observation in the present moment reaches backward across space, determining history. When you truly absorb the implications of this, it can feel like the solid ground beneath your feet is slowly dissolving into a gentle, shimmering mist. Wheeler realized that if our observations today can shape the history of a single photon over billions of years, then perhaps the very existence of conscious observers in the present is what collapsed the quantum wave function of the entire early universe. He envisioned a cosmos that begins in a state of indefinite quantum haze, expanding and cooling over billions of years in a quiet, uncertain silence. Eventually, through the slow, blind mechanisms of stellar evolution and chemistry, conscious beings evolve. These beings open their eyes, build telescopes, and look out into the vast night. And in that very moment of observation, they retroactively bring the entire history of the universe into concrete existence. We are not just an accidental byproduct of a mechanical universe. We are the essential ingredient that makes the universe real. This concept is often visualized as a letter U with an I at one end, looking back at its own origin at the other end. The universe brings life into existence, and life brings the universe into reality. It is a beautiful, deeply poetic vision of existence, blending the rigorous mathematics of quantum theory with the kind of contemplative wonder usually found in ancient philosophies. It suggests that the journey of learning and discovery is not merely a passive gathering of facts, but an active, creative participation in the ongoing construction of reality itself. Every time you look up at the stars, every time you wonder about the mysteries of the cosmos, you're not just seeing the universe, you're holding it together. Of course, many physicists recoil from this interpretation. It challenges the fundamental assumption of objective reality that has guided science for hundreds of years. The idea that a conscious mind is required to finalize reality feels too anthropocentric, too close to mysticism for comfort. To avoid this, scientists have proposed alternative interpretations of quantum mechanics, some of which are even stranger. One such alternative is the many worlds interpretation proposed by Hugh Everett in the 1950s. Everett suggested that wave functions never actually collapse at all, but rather the universe branches. In this view, every time a quantum event has multiple possible outcomes, the entire universe splits into separate, parallel realities, each containing one of the possible results. There is a universe where you saw the photon travel as a wave, and an identical universe where a slightly different version of you saw it as a particle. This interpretation removes the need for a special observer to collapse reality, but it requires us to believe in an endless, sprawling labyrinth of parallel realities expanding infinitely with every passing microsecond. Every possible history exists in some unreachable corner of this vast cosmic web. While this idea preserves the objectivity of physics, it stretches our sense of wonder to its absolute breaking point, painting a picture of a cosmos so staggeringly immense that human comprehension becomes almost impossible. Whether you find peace in the idea that our consciousness shapes reality, or whether you prefer the infinite, quiet branching of the many worlds, the core truth remains unchanged. The universe is fundamentally stranger than our senses can perceive. The solid, predictable world we experience every day is a convenient simplification created by our brains to help us navigate our immediate surroundings. But beneath this comforting veneer lies a deep, shimmering mystery, a quantum reality that defies common sense and invites us to question the very nature of existence. When we confront these mysteries, we should not feel fear or confusion. Instead, we should feel a profound, gentle humility. The fact that the universe operates in ways that are so deeply counterintuitive is not a flaw in our understanding. It is a testament to the boundless creativity and infinite depth of nature. It means there will always be more to discover. The quantum realm teaches us that the cosmos is not a dead, mechanical machine, but a dynamic, interactive puzzle. It is a place of endless possibility, where the boundaries between the observer and the observed begin to blur and fade away. As we continue this journey together, we will explore even deeper layers of this mystery, searching for answers within the quiet architecture of reality itself. The journey into the unknown is a beautiful meditation on our place in the grand cosmic order. We are explorers standing on the shores of an infinite ocean, gently dipping our toes into waters that hold secrets older than time. There is so much more to see, so much more to understand, and we have only just begun to open our eyes. Have you ever looked up at a distant flickering star on a clear, cold night and felt a sudden, inexplicable connection to it, as if the vast empty space between you and that ancient point of light did not truly exist? We are taught from a very young age that distance is an absolute barrier. If something is far away, it is separated from us by the rigid laws of physics. The speed of light, which travels at an astonishing 186,000 miles per second, is the ultimate cosmic speed limit. Nothing, we are told, can cross the quiet expanse of the universe faster than that. It takes minutes for the sun's warmth to reach our skin, and billions of years for the faint glow of the earliest galaxies to wash over the Earth. This fundamental rule gives our universe a comforting structure, where cause always precedes effect. But as we journey deeper into the quantum realm, leaving behind the familiar shores of our everyday reality, we encounter a phenomenon so utterly bizarre that it caused even the greatest minds of the 20th century to question the foundations of physics. This phenomenon suggests that space itself might be nothing more than a persistent illusion. This brings us to a concept known as quantum entanglement, a profound scientific mystery that binds the universe together in a web of invisible, instantaneous connections. To understand this beautiful and unsettling mystery, we must first imagine two tiny particles, perhaps two electrons or two photons of pure light, born together in the fiery heart of a primordial star, or created simultaneously in a modern laboratory. Because they share the same origin, their quantum states become inextricably intertwined, locked together in a delicate, perfectly synchronized cosmic dance. In the rigorous language of quantum mechanics, they are no longer independent entities. They are described by a single, shared wave function that encompasses them both. Now, imagine taking one of these entangled particles and keeping it carefully isolated here on Earth, while sending the other particle on an epic journey across the vast, dark emptiness of space, perhaps all the way to the Andromeda Galaxy, which sits 2,500,000 light-years away. According to our everyday human intuition, and according to the classical laws of physics, these two particles are now completely and permanently isolated from each other. Whatever happens to the particle resting quietly on Earth should have absolutely no effect on the particle floating in the silent, freezing void near Andromeda. To assume they could still influence one another seems like magic, completely contrary to scientific reason. But when scientists actually perform this exact type of experiment with entangled particles, separating them by miles, through fiber optic cables, or beaming them to orbiting satellites, something genuinely miraculous occurs. If you gently measure the spin or the position of the particle here on Earth, you collapse its wave function, forcing it to abandon its state of infinite possibilities and choose one definite reality. In that exact, indivisible fraction of a millisecond, the particle located in the distant galaxy instantly and perfectly mirrors that choice, assuming the corresponding state without any time delay whatsoever. It does not take 2,500,000 years for a signal to cross the universe and tell the second particle what to do. The reaction is completely instantaneous. It is as if the space between them simply does not exist. The legendary physicist Albert Einstein was deeply troubled by this idea. He famously referred to it as spooky action at a distance, a phrase that perfectly captures his profound discomfort. He simply could not accept that two separate objects could communicate faster than the speed of light, because it directly violated his beautiful theory of relativity, which dictates that absolutely no information can travel infinitely fast. For decades, scientists assumed there must be a logical, classical explanation for this strange behavior. They hypothesized that there must be some hidden variables, some secret mechanical instruction manual carried internally by the particles from the exact moment they were created, telling them exactly how to behave when measured in the future. It was a deeply comforting thought, a way to maintain the safe, predictable boundaries of a classical universe where things only affect their immediate surroundings. But in the 1960s, a brilliant physicist named John Stuart Bell devised a complex mathematical theorem that finally allowed scientists to test this comforting assumption in the real world. When the delicate experiments were finally conducted with sufficient technological precision, the results were definitive and shocking. There were absolutely no hidden variables. The particles were not consulting a predetermined script. The instantaneous, spooky connection was entirely real. Bell mathematically proved that our universe is fundamentally non-local, meaning that events happening in one specific location can instantaneously affect events happening in another completely different location, regardless of the vast, silent distances separating them. The quiet rules of the quantum world completely override the rigid boundaries of everyday space. This scientific revelation shakes the very ground we walk on and challenges our most basic perception of reality. If space cannot truly separate two entangled pieces of matter, then what exactly is space? Some of the most forward-thinking modern physicists are now exploring the radical, mind-bending idea that space and time themselves are not the foundational building blocks of the cosmos at all. Instead, they might be emergent properties, macroscopic illusions created by a much deeper underlying microscopic network of entangled quantum information. Imagine standing close to a beautiful, ancient tapestry woven by a master artist. When you look very closely at the fabric, you see only thousands of individual threads interacting in seemingly chaotic patterns. It is only when you step back and view the tapestry from a distance that the illusion of a continuous, cohesive picture emerges. In exactly the same way, the smooth, continuous space we navigate every day might just be the macroscopic illusion created by the infinite, microscopic web of quantum entanglement. The universe, in its most fundamental state, might not be a collection of isolated objects separated by empty voids, but a single, indivisible whole, intimately and instantaneously connected across the boundless depths of eternity. Take a moment to consider what this profoundly means for your own personal existence in this vast cosmos. The atoms that currently make up your physical body, the carbon vibrating in your cells, the oxygen filling your lungs, the iron flowing quietly through your blood, were all forged in the incredibly dense, fiery hearts of dying ancient stars billions of years ago. During those ancient, violent stellar explosions that scattered these elements across the galaxies, countless subatomic particles interacted intimately and became deeply entangled before being blown out into the endless cosmic winds. Over billions of years, many of those specific particles eventually coalesced, pulled together by the gentle hand of gravity, to form the Earth, the deep oceans, and ultimately, you. But the quantum partners of those particles, the ones they were deeply entangled with in that primordial stellar furnace, might now be floating on the exact opposite side of the observable universe. In a very real, scientifically rigorous sense that defies our common sense, you are physically and instantaneously connected to the absolute furthest reaches of the cosmos. You are not a solitary, isolated observer walking blindly through an alien universe. You are an active, tightly integrated thread in the vast, shimmering fabric of universal reality. This beautiful, scientifically verified interconnectedness invites us to adopt a perspective of gentle humility and profound peace. When we truly realize that the physical boundaries we perceive daily, the imaginary lines that seem to separate here from there, past from present, and us from the rest of the universe, are merely temporary illusions born from our limited biological senses, our fear of the unknown begins to fade. Our ignorance transforms into a powerful, driving motivation to keep exploring and learning. We do not need to feel intimidated by the complex mathematics or the mind-bending paradoxes that quantum physicists wrestle with. We only need to cultivate our natural, innate sense of wonder. The greatest scientific minds in human history, the brave pioneers who first mapped this strange territory, did not find definitive answers that closed the book on human discovery. Instead, they opened a heavy door to a much larger, more mysterious, and infinitely more beautiful room. They showed us with absolute mathematical certainty that the cosmos is not a rigid, dead machine ticking down to zero, but a gentle, breathing, interconnected entity of infinite potential. The more carefully we look, the more the universe reveals its astonishing creativity, gently challenging us to expand our minds. We are only just beginning to decipher the quiet, elusive language of the quantum world, standing like ancient philosophers on the shore of a vast, unexplored ocean. Every new scientific discovery about entanglement, every new satellite experiment that pushes the boundaries of what we consider physically possible, serves as a gentle, comforting reminder of how much beautiful mystery remains hidden in the dark. The journey of scientific understanding is not a straight path with a final destination where all questions are permanently answered. Rather, it is an endless, breathtaking exploration, a perpetual unfolding of mystery upon mystery, layer upon layer of reality, waiting to be gently uncovered. The universe actively invites us to participate in this journey, to continually question our most basic assumptions about reality, and to find a profound sense of inner peace in the simple fact that we belong to something so much grander and older than we ever could have imagined. As we prepare to delve into the next mesmerizing layer of this cosmic puzzle, venturing into the strange relationship between the flow of time and the ever-present observer, I invite you to carry this feeling of profound connection with you. The journey continues, and the universe is waiting. Have you ever sat quietly by a window, watching the rain fall, and felt that the flow of time itself had suddenly slowed to a gentle crawl? We experience time as an unstoppable river, carrying us forward from the ancient past toward an unknown future. We wear watches to measure this flow, dividing our days into predictable hours. We believe time is an absolute framework, a stage upon which the cosmos unfolds in a strict sequence. But what if this deep-seated intuition is a localized illusion? What if the quantum realm, the silent foundation of all reality, operates completely outside the boundaries of past, present, and future? To explore this mind-bending possibility, we must gently peel back everyday experience and peer into one of the most profound paradoxes uncovered by modern science. We must confront the disturbing idea that the act of observation not only determines the physical state of matter in space, but also dictates the very flow of time itself. In our everyday world, cause always precedes effect. A glass shatters, and then the sound reaches your ears. The sequence is strictly ordered by the arrow of time, a concept formalized by Sir Isaac Newton, and later beautifully refined by Albert Einstein's theory of relativity. Einstein proved that time is remarkably flexible, bending under the immense influence of gravity and velocity. Yet, even in Einstein's relativistic universe, the fundamental arrow of time remained intact. Events followed a logical sequence from past to future. But when physicists focused on the infinite, microscopic silence of the quantum realm, they discovered that even Einstein's flexible time was insufficient to explain the bizarre, deeply counterintuitive behavior of subatomic particles. Hello, my wonderful friends. As we pause to reflect on these timeless concepts, I want to formally welcome you if you are new here. I am Theodore, the researcher, your companion on this beautiful journey of discovery. Our analytics show that 71% of the people who watch these videos and share in our wonder have not subscribed to the channel yet. If you appreciate these contemplative explorations of the universe and wish to support our mission, please take a brief moment to subscribe. It helps us tremendously and ensures that our growing community of curious minds can continue to wander through these quiet mysteries together. Now, let us return to the fascinating enigma of quantum time and the absolute power of the observer. To truly grasp how the observer disrupts the flow of time, we must examine a highly sophisticated variation of the double-slit experiment, known as the delayed choice quantum eraser. This specific experiment is designed to trick the universe to see if we can observe a particle after it has already made its final physical decision. Imagine firing single photons of pure light through the apparatus. If we do not directly observe which slit the photon passes through, it acts as a spreading wave of infinite probability, gracefully creating a beautiful interference pattern on the screen. If we place a detector to observe its path, it behaves exactly like a solid particle, and the interference pattern disappears. Instead of observing the photon at the slits, physicists allow it to pass through completely unobserved. Immediately after passing through, the photon is passed through a special crystal that splits it into two identical, perfectly entangled twin photons. One twin photon, which we will refer to as the signal photon, travels directly to the main screen to be permanently recorded. The other twin photon, known as the idler photon, is sent into a complex maze of mirrors leading to advanced detectors. The crucial element of this setup is that the physical path of this idler photon is intentionally constructed to be much longer. This ensures the signal photon hits the main screen and its position is permanently recorded before the idler photon ever reaches its own detectors. The detectors in the maze are designed to do one of two things entirely at random. Either they reveal exactly which original slit the photon passed through, or they erase that crucial path information completely, making it forever impossible to know the true path. Because the twin photons are deeply entangled, whatever happens to the idler photon should instantly correlate with the signal photon. But we must remember the most critical detail. The signal photon has already hit the screen. When physicists run this meticulously controlled experiment, the results challenge the very core of our understanding of reality. When the maze randomly chooses to reveal the exact path of the idler photon, the corresponding signal photon, recorded slightly earlier in the unbroken flow of time, forms a simple, solid particle pattern on the screen. However, when the maze randomly chooses to permanently erase the path information, the corresponding signal photon forms an intricate, beautiful wave interference pattern. The specific action taken on the idler photon, the choice to observe its path or deliberately erase that knowledge, dictates the exact pattern formed by the signal photon, even though the signal photon completed its entire journey before the choice was actually made. The act of observation in the present moment, literally, retroactively, changes the physical behavior of the particle in the past. It is as if the entire universe holds its breath, suspending the tiny photon in a strange state of unresolved history. This astonishing experiment suggests that the quantum universe does not experience time sequentially as we humans do. Instead of a flowing one-way river, reality at its most fundamental level might be more like a vast static web of probabilities where past, present, and future are deeply interconnected, fluid, and constantly negotiating with one another. The exact moment a conscious observer gains knowledge about a quantum system is the precise mechanism that forces this fluid web to solidify into a definite historical narrative. This retroactive effect is not limited by our current technological constraints. If we could build a delayed choice quantum eraser on a cosmic scale, using ancient light from distant galaxies and the gravitational lensing of massive superclusters, the exact same quantum principles would apply. An observation made by an astronomer today, deciding whether to measure the path of an ancient photon or erase that information, would physically determine the fundamental behavior of that photon billions of years ago. How do we find inner peace in a vast cosmos where our present actions can rewrite the microscopic history of the universe itself? The profound answer lies in cultivating an endless sense of wonder and deep intellectual humility. Our human brains, beautifully evolved to hunt for food and build safe shelters on a single rocky planet, are simply not equipped to intuitively comprehend the true nature of time and space. We currently perceive the universe through a narrow, highly filtered biological lens, seeing only a tiny fraction of the infinite complexity that surrounds us. The unrelenting flow of time we experience is a macroscopic illusion, a necessary biological construct that allows us to function and survive. But beneath this comforting illusion lies a hidden reality of breathtaking mathematical elegance and fluid, shifting mystery. When we quietly study quantum mechanics, we are slowly, deliberately lifting the heavy veil of our own biological limitations. This realization should not bring existential fear, but rather a deeply comforting sense of intellectual freedom. If time is not a strict, unyielding prison that drags us kicking and screaming toward the end, but rather a flexible, interconnected canvas shaped by the presence of observation and conscious knowledge, then our role in the universe is infinitely more significant than we ever dared to imagine. We are active, vital participants, co-creators in an endlessly unfolding cosmic masterpiece. Our awareness, our innate curiosity, and our relentless desire to understand the deep mysteries of existence are the very forces that bring the universe into sharp physical focus. The absolute silence of the night sky is not empty space. It is brimming with endless, shimmering quantum potential, waiting patiently for a conscious human mind to look up, ask a question, and give it a definite shape. The ancient starlight traveling for billions of years is a delicate quantum wave reaching out through the dark. As we contemplate the fluid nature of time and the staggering retroactive power of the ultimate observer, we are forced to gently redefine what it truly means to exist. We are physically bound to the present moment, yet we are fundamentally entangled with the deep, primordial past and the distant, unfolding future. The entire universe is a single, magnificent, interconnected whole, spanning billions of light years across space and billions of years of complex history. And you are an inseparable, absolutely vital part of it. Your consciousness, your unique ability to observe, reflect, and wonder is the quiet, invisible key that unlocks the physical reality of the cosmos. Let this profound thought gently fill you with peace. Let the great mystery of time wash over you, reminding you constantly that there is so much more to our existence than our daily worries and fleeting struggles. We are standing bravely on the threshold of an infinite journey, slowly learning to read the elusive language of nature itself. The path ahead is vast, mostly unexplored, and wrapped in shadows, but the universe gently invites us to continue walking with open minds and open hearts. Have you ever stood beside a close friend, looking up at the exact same beautiful night sky, and wondered if they are truly seeing the exact same stars that you are seeing? We live our entire lives with the gentle assumption that the physical world is an objective, shared space. We believe that if a tree falls in a quiet, ancient forest, it falls in exactly the same way for every creature that happens to be watching. This shared reality is the foundation of our human experience, the comforting bedrock upon which we built our societies, our relationships, and our understanding of the vast cosmos. But as we continue our journey deeper into the strange, infinite silence of the quantum universe, we must confront a mystery that challenges this very assumption. What if the universe is not a single, objective stage upon which we all simply exist? What if At the most fundamental level of reality, your universe is entirely and uniquely your own. To explore this unsettling yet profoundly beautiful concept, we must turn to a thought experiment that has kept physicists awake for decades, quietly pondering the nature of truth. Hello, my fellow travelers. I am Theodore, the researcher, your quiet guide through the cosmic dark. I have noticed that 71% of the people who watch our videos and share in these moments of wonder have not yet subscribed to the channel. If you find peace and a gentle sense of belonging in exploring these profound mysteries, please take a moment to subscribe. It helps us greatly, allowing this community of curious minds to continue our endless journey together. Let us now return to the quiet mystery of our subjective reality. In the 1960s, a brilliant physicist named Eugene Wigner proposed an extension of the observer paradox that pushed the boundaries of quantum mechanics to their absolute philosophical limits. It is known as Wigner's friend. Imagine a perfectly sealed, perfectly quiet laboratory. Inside this laboratory is a scientist, the friend, conducting a delicate quantum experiment. They are observing a particle, waiting for its wave function to collapse into a definite state, perhaps spinning up or spinning down. When the friend looks at the measuring device, they become the observer. For them, the infinite probabilities vanish and reality solidifies into a single, concrete fact. They now know exactly what the particle is doing. But Wigner asked us to step outside that laboratory and imagine a second observer, Wigner himself, standing quietly outside the sealed door. From Wigner's perspective outside the closed room, he does not know the result of his friend's measurement. According to the strict mathematical rules of quantum mechanics, until Wigner opens that door and asks his friend what happened, the entire laboratory, including the particle, the measuring device, and the conscious friend inside, exists in a giant, shimmering state of quantum superposition. To the friend inside, reality has already collapsed into a definite state. But to Wigner outside, the friend is simultaneously in a state of having seen the particle spin up and having seen the particle spin down. It is only when Wigner gently opens the door and communicates with his friend that his own wave function collapses, and the two realities finally merge into one shared history. This sounds like a purely theoretical puzzle, a mathematical game played by ancient minds trying to break the rules of logic. But in recent years, scientists have actually performed microscopic versions of this exact experiment, using entangled photons acting as the observer and the friend. The results are utterly staggering. When the measurements are carefully compared, the mathematics prove that both observers were completely correct in their conflicting realities. The friend inside the system measured a definite outcome, while the observer outside the system correctly measured a continuing state of infinite superposition. The terrifying and beautiful conclusion drawn by many physicists is that quantum mechanics does not describe an objective reality at all. Instead, it describes a subjective reality, a deeply personal experience of the cosmos that is unique to every single observer. If reality is inherently subjective, we must completely reimagine our place in the vast, ancient universe. When you look up at the Milky Way, you are not simply passively receiving ancient light from a shared, objective void. Your conscious observation is actively carving a specific reality out of a boundless ocean of quantum possibilities. The stars you see, the planets orbiting them, the infinite silence of the deep space between them, these take on their specific properties in relation to your unique perspective. The universe is not a single, grand painting that we all simply stare at. It is a kaleidoscope of shifting probabilities, rendering a slightly different, deeply personal masterpiece for every single mind that dares to look. This realization can feel isolating at first, a gentle tremor shaking the foundation of our shared existence. If my reality is fundamentally different from your reality before we communicate, how can we ever truly connect? But there is a profound, comforting beauty hidden within this quantum mystery. It means that the cosmos is infinitely richer and more complex than a mere collection of dead matter. It is a participatory tapestry, woven together by the countless overlapping observations of every conscious being. Every time we share a thought, every time we speak about the wonder we feel when looking at the night sky, we are doing something far more magical than simply exchanging information. We are literally entangling our realities. We are opening the laboratory door, collapsing our individual wave functions into a beautifully shared, cooperative universe. Think about the staggering scale of this cosmic cooperation. Our planet is home to billions of human minds, alongside countless other forms of life, all constantly observing, constantly pulling definite shapes out of the quantum mist. Now extend that thought outward, past our quiet solar system, past the spiraling arms of our home galaxy, out into the endless ocean of the observable universe. There are trillions of galaxies out there, containing more stars than there are grains of sand on all the beaches of Earth. If conscious life exists out there in the vast dark, if there are other minds looking back at the same ancient cosmos, they are also participating in this grand, continuous creation of reality. The universe is a symphony of observation, a chorus of minds actively weaving the fabric of space and time simply by bearing witness to it. We often feel so small, so completely insignificant when confronted with the immense scale of the cosmos. We are tiny, brief sparks of life clinging to a damp rock, floating through an endless, freezing void. But the quantum observer effect, especially when viewed through the lens of subjective reality, completely reverses this perspective. The universe is not just vast, it is entirely dependent on the presence of an observer to give it a definite shape. The ancient starlight, the spiraling galaxies, the deep, mysterious nebulae. They are all waiting in a state of quiet, unresolved potential until a mind reaches out to perceive them. You are not a meaningless speck in an indifferent machine. You are the quiet center of your own universe, the essential focal point where infinite possibilities gently collapse into the beautiful, structured reality you experience right now. Let this thought wrap around you like a soft, warm blanket. Your everyday life, with all its simple moments and quiet routines, is not separate from the grand cosmic mysteries. It is the very stage upon which those mysteries are continuously resolved. When you wake up in the morning and look out your window at the soft light of dawn, you are actively participating in the ancient, ongoing creation of the cosmos. Your consciousness is the gentle force that anchors the universe, transforming a chaotic haze of mathematical probabilities into the solid, beautiful world you can touch, feel, and love. There is a deep, profound peace to be found in this realization. It strips away the anxiety of feeling disconnected and replaces it with a gentle, enduring sense of cosmic belonging. Our journey through this strange reality is far from over. There are still so many dark corners to illuminate, so many paradoxes to unravel, and so much more wonder to experience. But for now, take a deep, quiet breath and simply exist in the magnificent, subjective universe that your very presence is actively helping to create. Have you ever walked through an ancient silent forest completely alone, and wondered what happens to the world the exact moment you close your eyes. We have explored the deeply unsettling idea that your conscious observation carves your personal reality out of a shimmering ocean of quantum possibilities. But this beautiful, terrifying thought immediately gives birth to an even larger, more profound paradox. If reality requires an observer to gently force it into a solid state, then what happens when we are all asleep? What keeps the towering mountains, the deep, dark oceans, and the ancient spiraling galaxies from simply dissolving back into a hazy, undefined cloud of infinite probabilities? We trust that the universe remains perfectly intact when we turn our backs. We believe the moon is still shining quietly in the cold, dark void, even if not a single human eye is looking up at it. But in the strange, microscopic mathematics of quantum mechanics, this comforting permanence is not guaranteed. To resolve this paradox, physicists were forced to search for the end of the chain, the final, ultimate observer that holds the entire cosmos together in a continuous, waking dream. Hello again, my fellow explorers of the unknown. As we venture deeper into this beautiful, silent mystery, I would like to pause and warmly welcome you to our quiet community. I am Theodore, the researcher, your companion in this endless cosmic journey. I have gently noticed that 71% of the people who watch our videos and share in these moments of profound wonder have not yet subscribed. If you find peace and a gentle sense of belonging in exploring these ancient existential questions with us, please take a moment to subscribe. It helps us incredibly, ensuring that our community of curious minds can continue to wander through these quiet mysteries together. Now, let us return to the fascinating enigma of the ultimate observer and the hidden architecture of reality. To understand the search for this ultimate observer, we must first look at a concept proposed by the brilliant mathematician John von Neumann. In the 1930s, von Neumann mathematically formalized the quantum measurement problem. He traced the journey of a particle from a state of infinite superposition, traveling through the measuring device, traveling through the optic nerve of the scientist, and finally reaching the brain. He realized that the mathematics of quantum mechanics did not provide a natural stopping point for the superposition. If the particle is in a haze of probabilities, and it interacts with a mechanical detector, the detector should also enter a state of superposition. If the scientist looks at the detector, the scientist's brain should mathematically become entangled in that same infinite, undefined state. This infinite sequence of entanglements is known as the von Neumann chain. According to the pure mathematics, this chain can extend indefinitely, wrapping the entire universe in a ghostly, undefined fog. But obviously, that is not what we experience. We experience a solid, definite reality. Something, somewhere along the line, must break the chain. Something must be fundamentally different from regular matter, possessing the unique, mysterious power to collapse the wave function and bring the physical world into sharp focus. For von Neumann and several of his contemporaries, that unique, unquantifiable element was human consciousness itself. They argued that the mind, sitting gently outside the rigid laws of physical matter, is the only thing capable of terminating the chain. But this leads us back to our terrifying paradox. If human consciousness is the only thing collapsing reality, then the universe was a meaningless, undefined blur for 13,800,000,000 years before we arrived. Furthermore, the cosmos is far too vast, too impossibly ancient, and too immensely complicated to be held together by the fragile, fleeting minds of human beings alone. If we are the only observers, vast stretches of the universe that we cannot see would remain in a state of suspended animation, waiting quietly for a telescope to find them. There must be another mechanism, a deeper phenomenon, that forces the universe to choose a definite shape. This profound realization led modern physicists to develop the theory of quantum decoherence. Decoherence is a gentle, beautiful explanation that attempts to bridge the vast gap between the strange, probabilistic world of the extremely small and the solid, predictable world we navigate every day. Instead of relying on a human mind, decoherence suggests that the environment itself acts as a relentless, silent observer. Imagine a single quantum particle completely isolated in the infinite vacuum of deep space. It can easily exist in a state of delicate superposition, exploring infinite possibilities simultaneously. But the universe is almost never completely empty. Space is filled with an ancient, invisible ocean of cosmic microwave background radiation, the lingering thermal glow of the Big Bang itself. It is filled with stray photons from distant stars, wandering atoms of hydrogen, and the subtle, invisible pull of gravity. The moment our isolated quantum particle interacts with even a single stray photon of ancient starlight, a tiny exchange of information takes place. The particle and the photon become gently entangled as the particle continues to interact with more and more elements of its environment, the dust, the light, the surrounding air. Its delicate quantum state quickly leaks out into the larger world. The superposition is not necessarily destroyed, but it becomes so impossibly entangled with the entire environment that the strange quantum effects are completely washed out, hidden in the overwhelming noise of the macroscopic universe. In this view, the universe is constantly, aggressively measuring itself. Every single atom is continuously bumping into other atoms, silently recording their positions, and forcing the surrounding reality to snap into a definite, solid state. The environment is the continuous observer. This provides a deeply comforting sense of intellectual safety. It tells us that the moon is indeed there when we are not looking, because the photons from the sun are constantly hitting the moon's dusty surface, and the immense gravity of the earth is constantly interacting with its mass. The universe does not need us to hold it together. It is actively, perpetually holding itself together through an infinite, microscopic web of physical interactions. The silent, empty rooms in your house do not dissolve into a quantum blur because the air molecules, the gentle ambient light, and the quiet, solid walls are constantly measuring one another, maintaining a stable, cohesive reality. But as with all things in the quantum realm, answering one profound question only opens the door to a deeper, even more unsettling mystery. Decoherence beautifully explains how the strange quantum superposition spreads out and hides in the environment, but it does not actually solve the core problem of the von Neumann chain. It does not explain why the universe chooses one specific reality out of the infinite possibilities available to it. If the entire environment becomes entangled with the particle, then, technically, the entire environment should just enter a massive, macroscopic state of superposition. The universe should still be a giant, undefined wave of probabilities, just a much more complicated one. To truly collapse the wave function, to truly force reality to become single and definite, many brilliant thinkers believe we must return to the idea of a conscious observer, but this time on a scale that completely defies human imagination. We are led to the concept of the ultimate observer, a universal consciousness that permeates every inch of reality. This is an idea known as panpsychism, and it is quietly gaining traction among those struggling to reconcile quantum mechanics with the physical world. Panpsychism suggests that consciousness is not a rare accident, but a fundamental property of the universe, exactly like mass or the gentle pull of gravity. Just as an electron possesses an intrinsic amount of negative charge, it might also possess a tiny, primitive spark of awareness. As atoms gently join to form biological structures, these tiny sparks combine, blooming into the human consciousness we experience. If consciousness is a fundamental property of all matter, then the entire universe is quietly aware. The endless void is humming with a primordial perception. This universal awareness acts as the ultimate observer, the ever-present mind that effortlessly collapses the wave function of the entire cosmos into a concrete reality. The universe exists because it is continually observing itself. You are not a stranger in a cold machine. You are a localized node of the universe waking up, finding deep peace in the simple act of being aware. Have you ever made a choice that completely changed the trajectory of your life, and quietly wondered if you were destined to make that exact decision since the very dawn of time? We have explored the beautiful, overwhelming concept of panpsychism, the idea that a primitive, universal awareness permeates every single atom, acting as the ultimate observer that collapses the infinite quantum wave of the cosmos into a solid, breathing reality. We found a deep, gentle peace in the realization that we are not isolated biological accidents, but localized nodes of a universe that is constantly, quietly waking up to observe itself. But this profound realization introduces a new, deeply personal tension into our journey. If the universe is one vast interconnected web of quantum information, constantly measuring itself and determining its own state through an ancient, inherent consciousness, where does that leave our human sense of agency? Do we actually possess the freedom to choose our own paths through the quiet dark? Or are our choices simply the inevitable result of microscopic quantum dominoes falling exactly as they must, set in motion 13,800,000,000 years ago? Hello once again, my fellow travelers of the infinite. As we pause to reflect on the nature of our own freedom, I want to take a brief moment to welcome those who might be wandering with us for the first time. I am Theodore, the researcher, your gentle guide through these ancient cosmic mysteries. I have noticed that 71% of the people who watch our videos and share in this quiet wonder have not yet subscribed to the channel. If you find comfort and intellectual safety in these contemplative journeys, please consider subscribing. It helps us immensely, allowing this community of curious minds to continue exploring the beautiful, endless silence of the universe together. Now, let us return to the mystery of our own minds and the quantum nature of choice. To truly appreciate the weight of this existential question, we must look back to the towering minds of classical physics. For centuries, brilliant scientists like Sir Isaac Newton and Pierre-Simon Laplace envisioned a universe that operated like a perfect, flawless piece of clockwork. Laplace famously proposed a theoretical intellect, often called Laplace's demon, which possessed the ability to know the precise location and momentum of every single atom in the entire cosmos at any given moment. According to the strict, unyielding laws of classical mechanics, if this vast intellect knew the exact starting conditions of the universe, it could calculate the entirety of the past and predict the absolute entirety of the future with flawless mathematical certainty. In this rigid, mechanical vision of reality, every thought you have ever had, every word you have ever spoken, and every gentle act of kindness you have ever performed was mathematically predetermined the exact moment the universe began expanding. This classical view strips the cosmos of its mystery, reducing the beautiful, chaotic tapestry of human existence to a cold, unavoidable equation. It leaves no room for wonder, no room for genuine discovery, and certainly no room for free will. But as humanity peered deeper into the microscopic architecture of reality, the rigid, clockwork universe completely shattered. In the 1920s, the brilliant physicist Werner Heisenberg unveiled a foundational truth about nature that permanently erased the possibility of Laplace's demon. It is known as the Heisenberg uncertainty principle, and it is not merely a statement about the limitations of human technology. It is a profound declaration about the fundamental nature of the cosmos. Heisenberg mathematically proved that it is physically impossible to simultaneously know both the exact position and the exact momentum of a quantum particle. If you gently measure the precise location of an electron, its speed and direction become wildly, infinitely uncertain. Conversely, if you measure exactly how fast it is moving, its physical location dissolves into a blurry, undefined haze of probabilities. The universe inherently refuses to be perfectly known. At its most fundamental level, reality guards its secrets, maintaining a quiet, irreducible layer of randomness and unpredictability. The classical dream of a perfectly predictable universe dissolves into the shimmering, uncertain waters of the quantum realm. This intrinsic uncertainty is where the beautiful, terrifying possibility of true freedom quietly resides. If the universe is not a rigid machine following a predetermined script, but rather a fluid, unfolding canvas of probabilities, then the future is not yet written. The ancient, universal awareness that permeates the cosmos does not dictate a single, unavoidable path. Instead, it sustains an infinite field of potential, waiting for localized observers like you and me to gently interact with it and collapse those possibilities into a lived reality. Your conscious mind is an incredibly complex, highly organized system built from billions of interconnected neurons, each firing according to the strange, probabilistic rules of quantum chemistry. Some bold theoretical physicists and neuroscientists have even proposed that the human brain might utilize delicate quantum processes to generate consciousness itself, effectively making our minds microscopic quantum computers operating in the warm, wet environment of our biology. While this specific theory remains deeply controversial, the broader philosophical implication is inescapable. We are creatures born of quantum uncertainty, navigating a cosmos that inherently allows for infinite branching paths. When you make a difficult choice, you're not simply acting out a script written billions of years before your birth. You are actively participating in the ongoing, creative evolution of the universe. In that quiet moment of decision, the infinite possibilities of the quantum field gently collapse, and you forge a new, entirely unique path through the vast dark. This realization should not fill us with the anxiety of immense responsibility, but rather with a profound, quiet peace. It means that your life is a genuine, unscripted journey of discovery. Every time you look up at the ancient stars, every time you choose to learn something new, and every time you embrace the deep mystery of existence, you are an active force of creation. The universe is not happening to you, it is happening with you. The vast, infinite silence of the cosmos is not an empty void waiting to swallow us, but a gentle, accommodating space that gives us the profound freedom to simply be. We belong here, not as cogs in a cosmic machine, but as vital, creative sparks in a universe that is still deciding what it wants to become. Let us take a moment to truly internalize the scale of this freedom. When we look at the cosmic microwave background radiation, the ancient, cooling afterglow of the universe's fiery birth, we see tiny, microscopic fluctuations in temperature. These ancient imperfections, born from completely random quantum fluctuations in the very first fractions of a second of time, eventually grew under the slow, patient pull of gravity to become the massive galaxy clusters and spiraling superstructures that fill the cosmos today. The entire macrocosm, the grand architecture of the universe itself, owes its existence to the tiny, unpredictable freedom of the quantum realm. If those primordial quantum particles had followed a rigid, predictable set of classical rules, the universe would have expanded into a perfectly smooth, perfectly uniform, and entirely dead void. There would be no stars, no planets, and no conscious minds to wonder about them. The very existence of beauty, complexity, and life is the direct result of the universe's inherent refusal to be predetermined. Your own freedom is a direct, unbroken continuation of that original primordial spark of uncertainty. As we stand on this precipice of understanding, looking out into the gentle, starlit dark, we realize that our ignorance is our greatest asset. It is precisely because the universe cannot be perfectly predicted that life has any meaning at all. The mystery is not a puzzle meant to be entirely solved and discarded. It is the very fabric of our existence, a continuous invitation to explore, to dream, and to marvel at the sheer improbability of our own awareness. Our journey through the quantum landscape has shown us that reality is deeply subjective, interconnected across vast distances, entirely dependent on observation, and fundamentally free from the chains of strict determinism. But this journey is far from over if our choices actively collapse the wave function of reality, forcing the universe to select one path out of infinite possibilities. What happens to all the paths we did not choose? Do they simply vanish into nothingness? Or do they continue to exist, expanding outward in a quiet, invisible realm, forever separated from our own? As we prepare to turn our gaze toward the staggering concept of alternate realities, we must gather our courage and gently step beyond the boundaries of our single, isolated universe. Have you ever stood at a quiet crossroads in your life, made a difficult choice, and gently wondered about the life you would be living right now if you had simply turned the other way? We walk through our days believing that our path is singular, a lone thread woven through the vast, dark tapestry of time. We experience a single, unbroken narrative, a continuous journey from the ancient past into the unknown future. When we choose one path, we assume the other path simply ceases to exist, fading into the silent mist of missed opportunities and forgotten dreams. We feel a deep sense of intellectual safety in this linear progression, trusting that the history we have lived is the only history that could ever possibly be. But as we peer even deeper into the beautiful, unsettling mystery of quantum mechanics, we encounter a scientific theory that completely shatters this comforting assumption. What if every choice you make, and every quantum event that occurs in the infinite cosmos, does not collapse reality into a single outcome, but instead splits the entire universe into diverging paths? This brings us to the profound, staggering concept of alternate realities, a realm where the quiet boundaries of our single existence melt away into an infinite, branching labyrinth of parallel worlds. Hello again, my friends. As we prepare to step across the threshold into this vast, unimaginable multiverse, I want to gently welcome you. I am Theodore, the researcher, your quiet companion on this beautiful journey of discovery. I have noticed that 71% of the people who watch our videos and share in this deep sense of wonder have not yet subscribed to the channel. If you find peace and a sense of intellectual safety in these contemplative explorations, please take a moment to subscribe. It helps us incredibly, ensuring that our community of curious minds can continue to wander through the quiet mysteries of the universe together. Now, let us return to the strange, infinite silence of quantum branching. To comprehend this mind-bending theory, we must return to the 1950s and the brilliant, deeply unconventional mind of physicist Hugh Everett III. When Everett first published his theory, it was met with cold silence and deep skepticism by the established scientific community. The idea was considered too radical, too bizarre for the serious halls of academia. Everett, disheartened by the response, eventually left the field of theoretical physics entirely. It took decades for other brilliant physicists to rediscover his work and truly realize its profound mathematical elegance. Today, the many worlds interpretation stands as one of the most rigorously debated and deeply respected frameworks in all of quantum mechanics. While most of his earlier colleagues were wrestling with the Copenhagen interpretation, the idea that a conscious observer forcibly collapses the quantum wave function from infinite possibilities into a single reality, Everett proposed a solution that was elegantly simple in its mathematics, yet profoundly disturbing in its philosophical implications. He suggested that the wave function never actually collapses at all. When a quantum particle exists in a state of delicate, infinite superposition, holding multiple contradictory possibilities at once, and an observation is finally made, the universe does not force the particle to choose just one path. Instead, the universe itself gently and silently splits. It branches into completely separate, distinct realities, each containing one of the possible outcomes. If a particle has an equal chance to spin up or spin down, there is one universe where you observe it spinning up, and a completely parallel, equally real universe where a slightly different version of you observes it spinning down. Both realities are fundamentally valid, completely physical, and utterly unaware of each other's existence. The observer does not collapse the wave. The observer simply becomes entangled with it, splitting along with the universe itself. Imagine the staggering, almost terrifying scale of this continuous cosmic branching. Every single time a microscopic quantum interaction occurs anywhere in the vast, ancient universe, reality fundamentally divides. Consider that a single drop of ordinary water contains roughly 1.5 sextillion atoms, and each of those atoms is constantly interacting, vibrating, and making quantum choices in the dark. Now, gently extend that scale to the entire observable cosmos, stretching across 93 billion light-years of empty space, containing hundreds of billions of magnificent spiral galaxies, each holding hundreds of billions of burning stars. Trillions upon trillions of microscopic quantum events are happening every single microsecond in the fiery, violent hearts of ancient suns, in the quiet, freezing clouds of interstellar dust, and within the very firing neurons of your own brain. With every indivisible fraction of a second, the universe fractures into an unquantifiable, mind-bending number of parallel realities. We are not living in a single, solitary cosmos drifting through the void. We are riding the crest of an infinitely expanding wave of realities, a multiverse so breathtakingly vast that human mathematics and language can barely contain its true proportions. The legendary astronomer Carl Sagan once beautifully remarked that the cosmos is within us, that we are made of star stuff, and that we are a way for the universe to know itself. In the strange, illuminating light of the many worlds interpretation, this poetic truth takes on an even more profound, multi-dimensional meaning. If every possible outcome of every quantum event actually happens, then the universe is not just exploring one single linear way to know itself. It is actively, simultaneously exploring absolutely every possible way. Somewhere out there in the infinite silence of the multiverse, there is a quiet, parallel reality where the ancient asteroid narrowly missed the Earth 66 million years ago, and giant, reptilian creatures still roam beneath a strange, unfamiliar sky. There is a reality where our sun was born slightly smaller, burning with a faint red glow, casting long, dark shadows over a frozen, completely lifeless Earth. There is a reality where the Voyager spacecrafts were never launched, and their golden records do not currently drift through the silent interstellar medium. And there is a reality where you, in this exact moment, made a completely different choice this morning, leading to an entirely different cascade of events. Every variation, every subtle whisper of possibility, is physically realized in the infinite, expanding architecture of the multiverse. This concept can easily overwhelm the human mind, creating a profound sense of existential vertigo as we stare into the bottomless depths of infinite variations. If everything that can possibly happen actually does happen in some unreachable, parallel branch of the multiverse, does it drain our specific, everyday reality of its meaning? Do our hopes, our dreams, and our deepest regrets become insignificant if every alternative is playing out somewhere else? The gentle, comforting answer from the heart of quantum physics is no. Our choices matter deeply, precisely because they determine which specific branch of the multiverse we consciously, physically experience. You are the ultimate observer navigating this infinite branching labyrinth, and the reality you perceive right now is the beautiful, unique culmination of an unbroken chain of choices and quantum events stretching back 13,800,000,000 years. Out of an endless shimmering sea of parallel worlds, you're here, breathing, thinking, and experiencing this exact precious moment. Your existence in this specific branch is a delicate astronomical miracle, a highly specific melody played perfectly in a grand cosmic symphony of infinite, silent variations. The regrets we carry for the paths not taken can gently fade away, replaced by the profound peace of knowing that every possibility has a home in the cosmos. We must embrace a profound, quiet humility when confronting a mystery of this unimaginable magnitude. We are tiny, brief sparks of biological consciousness floating in an ocean of realities so vast and ancient that they defy all human comprehension. Yet, the very fact that we can conceive of this multiverse, that we can use rigorous mathematics and bold, empathetic imagination to peer far beyond the physical boundaries of our own isolated existence, is a testament to the incredible, boundless power of the human mind. The quiet journey of scientific discovery constantly, gently reminds us that the universe is far stranger, far richer, and far more beautiful than our daily routines could ever suggest. We are not prisoners of a single unyielding timeline, but travelers navigating a garden of infinite branching paths. As we prepare to delve into the next, even deeper layer of this cosmic puzzle, we will gently turn our gaze away from the infinite expanse of parallel worlds and look inward, exploring how this ultimate observer effect and the continuous branching of reality might hold the very key to understanding the deep, ancient illusion of death itself. The journey is far from over, and the cosmos, in all its infinite variations, is patiently waiting. Have you ever experienced a moment in your life where time seemed to completely stop, perhaps during a sudden loss of balance near a steep edge or a near collision on a quiet, rain-slicked highway. And after walking away completely unharmed, you gently wondered how you managed to survive. We move through our daily lives with a profound, unspoken awareness of our own physical fragility. We understand that the biological vessel carrying our conscious mind is delicate, easily broken by the chaotic forces of the natural world. This awareness of our mortality shapes our deepest fears, our greatest loves, and our relentless search for meaning in a vast ancient universe. We view death as the ultimate, unyielding boundary, the final silence at the end of a singular, linear journey. But as we carry the staggering implications of the many worlds interpretation forward, applying the strange, branching mathematics of quantum mechanics to our own subjective experience, we are forced to confront a theory so radical, so profoundly comforting, and yet deeply terrifying, that it fundamentally rewrites the definition of mortality. What if, from the strict private perspective of your own consciousness, the universe simply does not allow you to die? Hello again, my fellow explorers of the deep unknown. Before we gently step into the shadows of this ancient mystery, I want to take a brief moment to welcome you. I am Theodore, the researcher, your quiet companion on this vast cosmic journey. I have noticed that 71% of the people who watch our videos and share in this profound sense of wonder have not yet subscribed to the channel. If you find a sense of peace and intellectual safety in exploring these ultimate boundaries of existence with us, please take a moment to subscribe. It helps us incredibly, ensuring that our beautiful community of curious minds can continue to wander through the quiet, infinite mysteries of the universe together. Now, let us return to the strange, unyielding persistence of the observer. To understand this astonishing concept, a concept physicists refer to as quantum immortality, we must return to one of the most famous thought experiments in the history of science, originally proposed by the brilliant physicist Erwin Schrödinger in the 1930s. You have likely heard of Schrödinger's cat, the paradoxical feline placed inside a sealed steel box with a tiny radioactive atom, a Geiger counter, and a glass vial of lethal gas. If the atom randomly decays, the counter detects the radiation, shatters the glass, and the cat gently passes away. If the atom does not decay, the cat remains perfectly unharmed, according to the standard Copenhagen interpretation of quantum mechanics. Before the thick steel box is opened and a conscious observer looks inside, the radioactive atom exists in a state of infinite superposition, both decayed and not decayed simultaneously. Therefore, the unfortunate cat must also exist in a blurry, undefined state of being both perfectly alive and eternally asleep at the exact same time. It is only when the scientist opens the heavy door that the wave function collapses into a single, concrete reality. But we must analyze this famous experiment through the elegant, branching mathematics of Hugh Everett's many worlds interpretation. And most importantly, we must radically shift our perspective. Instead of standing outside the steel box in the sterile laboratory, imagine that you are the conscious observer sitting quietly inside the box. When the critical moment of the quantum event occurs, the universe does not wait for an outside observer to collapse a single reality. Instead, the entire cosmos immediately, silently, branches into two parallel, equally real worlds. In one branch of the multiverse, the atom decays, the vial shatters, and your biological journey comes to a sudden, peaceful end. From the perspective of the scientist opening the box in that specific reality, you're simply gone. But in the second branch of the multiverse. The atom remains perfectly stable, the vial remains intact, and you continue to sit in the quiet dark, completely unharmed, waiting for the door to open. Here is the profound, mind-bending twist at the very heart of quantum immortality. A conscious mind can only ever experience a reality in which it exists. You cannot consciously experience the absence of your own consciousness. Therefore, from your own deeply subjective first-person perspective, the branch of the multiverse where the experiment fails simply goes completely dark, entirely unexperienced, and unrecorded by you. Your stream of awareness will absolutely, necessarily follow the branch of the universe where you survive. When the heavy steel door finally opens, you will step out into the laboratory, perhaps a little frightened, but perfectly alive. And if the scientist runs the brutal experiment again, and the universe splits again, your conscious awareness will once again be physically forced to follow the path of survival. You could run the quantum experiment 100 times, or 1,000 times, or 1,000,000 times. To the outside observer, the statistical odds of your survival are so infinitesimally small that they border on mathematical impossibility. But to you, the ultimate observer locked inside the system, you will survive every single time, experiencing a continuous, unbroken chain of miraculous luck, because your consciousness is entirely incapable of experiencing its own termination. When we gently expand this strange, microscopic thought experiment to the vast, chaotic reality of our everyday human lives, the implications become truly staggering. Every time you face a situation where a truly random quantum event dictates the boundary between survival and the end of your biological journey, the universe quietly branches to your family, your friends, and the external observers dwelling in one specific branch of the multiverse. You might gently slip away, returning your physical atoms to the ancient earth. They will mourn your passing, honoring the beautiful, finite time you shared in that specific reality. But from your own internal perspective, the quiet, observing center of your universe, you will inexplicably, miraculously survive. A sudden swerve of the steering wheel, a medical anomaly, a fortunate gust of wind. The cosmos will endlessly provide whatever highly improbable physical mechanism is required to ensure that your specific thread of consciousness continues to observe. This deeply counterintuitive theory does not promise eternal youth, nor does it suggest our physical bodies will not eventually succumb to the slow wearing of time and biological aging. The relentless, quiet increase of entropy remains firmly intact, but it suggests a profound, beautiful truth about the fundamental nature of awareness. The conscious observer is not a fragile, temporary spark extinguished by the chaotic winds of the physical world. Instead, consciousness appears to be an enduring property of the cosmic architecture, a persistent observer that relentlessly navigates the infinite, branching labyrinth of the multiverse, always finding the path that allows the gentle light of awareness to keep burning. The universe absolutely requires your specific mind to witness it. There is a breathtaking, profound peace found in this realization. It strips away the deep, primal fear of the final silence, replacing it with a gentle sense of cosmic continuity. You're not a brief visitor in an indifferent cosmos, waiting to be erased by a random roll of the quantum dice. You are a timeless, essential thread woven into the infinite fabric of reality. The atoms composing your form were forged in the fiery hearts of ancient stars, and they will eventually return to the quiet earth scattering across the universe to form new planets over billions of years. But the invisible, observing essence that looks out through your eyes, the quiet center that feels this immense wonder, will simply continue its journey through the infinite branches. We are eternal witnesses to a cosmos constantly reinventing itself. As we sit quietly with this comforting thought, we must prepare to ask the next logical question. If our awareness is a persistent, indestructible force, continuously shaping the branching reality of the multiverse, then what exactly is this reality made of? We have stripped away the illusions of solid matter, linear time, absolute space, and even the finality of death. What remains when we stare into the absolute bedrock of existence? As we prepare to turn the next page in our journey, we will explore the mind-bending possibility that the entire universe, with its ancient galaxies and its infinite branches, might fundamentally be nothing more than pure, shimmering information projected from the very edge of reality. Have you ever reached out to touch the rough, ancient bark of a towering oak tree, or felt the cool, smooth surface of a polished stone, and felt absolutely certain that the physical world is undeniably solid? We rely on our fragile senses to navigate this beautiful, chaotic reality. When we press our hands against a heavy wall, it pushes back with equal force. When we drop a glass on a hard floor, it shatters into pieces. Our entire biological existence is built upon the deeply comforting assumption that we inhabit a three-dimensional universe filled with physical, tangible matter floating endlessly through the vast, quiet depths of space. But what if this overwhelming sensation of physical solidity is the grandest, most beautifully orchestrated illusion of all? What if the towering mountains, the deep oceans, the spiraling galaxies, and even the physical vessel of your own body are not truly three-dimensional at all? To confront this profound ancient mystery, we must travel to the very edge of human understanding, venturing into a scientific theory so radically counterintuitive that it threatens to dissolve the physical universe into a shimmering mathematical mirage. We must explore the unsettling yet breathtaking possibility that our entire reality is a beautifully rendered hologram projected from the quiet, infinite edge of the cosmos. Hello, my fellow seekers of truth. As we prepare to gently peel back the very fabric of our perceived existence, I want to take a brief, quiet moment to welcome you to our gathering. I am Theodore, the researcher, your companion on this endless journey through the cosmic dark. I have noticed that 71% of the people who watch our videos and share in this profound sense of wonder have not yet subscribed to the channel. If you find peace and a gentle sense of intellectual safety in exploring these ancient, mind-bending mysteries with us, please consider taking a moment to subscribe. It helps us incredibly, ensuring that our beautiful community of curious minds can continue to wander through the infinite silence of the universe together, unraveling the secrets of the dark. Now, let us return to the strange, shimmering illusion of our holographic reality. To truly understand how the universe could possibly be a giant hologram, we must travel far away from the comforting light of our home sun and venture into the most extreme, terrifying, and beautifully mysterious objects in the entire cosmos: black holes. For decades, physicists believed that black holes were the ultimate cosmic erasers. The gravity of a black hole is so impossibly immense that nothing, not even ancient starlight traveling at an astonishing 186,000 miles per second, can escape its quiet grasp once it crosses the invisible boundary known as the event horizon. In the 1970s, the brilliant physicist Stephen Hawking, alongside Jacob Bekenstein, wrestled with a profound, deeply disturbing paradox. If a physical object falls into the dark silence of a black hole, all the complex quantum information that describes that specific object, the exact arrangement of its vibrating atoms, its unique chemical properties, its entire historical timeline, seems to simply vanish from the universe. But quantum mechanics strictly dictates that fundamental information can never be completely destroyed. This created a terrifying scientific contradiction that threatened to break the foundational laws of physics, pitting gravity against quantum theory in a battle for the nature of truth. The beautiful, mind-bending solution to this cosmic paradox forever changed our understanding of reality. Bekenstein and Hawking mathematically proved that when an object falls into a black hole, its delicate quantum information is not lost in the crushing density of the singularity at the center. Instead, that precious information is permanently smeared across the two-dimensional surface of the event horizon itself. Imagine dropping a bound three-dimensional book into the mouth of a black hole. The physical object is instantly gone, but the exact information contained within its pages is flawlessly translated and encoded onto the flat, invisible boundary surrounding the darkness. The three-dimensional object is perfectly preserved as two-dimensional data, and even more astonishingly, the total amount of information a black hole can hold is not determined by its three-dimensional volume, but entirely by the two-dimensional surface area of its event horizon. The information is divided into impossibly tiny units, known as Planck areas, the absolute smallest measurable scale in the universe, billions of times smaller than a single atom. This realization was profoundly unsettling. It meant that the ultimate truth of a three-dimensional object hiding inside a black hole is fully contained on a flat, two-dimensional surface. The mystery deepened exponentially in the late 1990s when theoretical physicist Juan Maldacena published a highly complex mathematical paper that sent shockwaves through the scientific community. Working within the intricate framework of string theory, Maldacena constructed a hypothetical universe and mathematically proved that the physical laws describing the three-dimensional interior of that universe were absolutely, perfectly equivalent to the mathematical laws describing a two-dimensional boundary completely surrounding it. He created a mathematical dictionary that flawlessly translated gravity and solid geometry on the inside into pure quantum information on the outside. Though Maldacena's specific model used a universe with slightly different geometrical properties than our own, the deep philosophical implications permanently altered the trajectory of theoretical physics. What if this staggering holographic principle applies to our own vast ancient universe? Imagine the entire cosmos stretching out across an incomprehensible 93 billion light-years containing trillions of magnificent galaxies and countless billions of burning stars. Now, gently imagine a quiet, invisible boundary surrounding absolutely all of it, a two-dimensional surface resting at the absolute edge of existence. According to the holographic principle, every single piece of three-dimensional matter, every burst of ancient starlight traveling through the void, every quiet emotion you have ever felt, and the very structure of your firing brain, is fundamentally encoded as pure, vibrating quantum information on that distant, two-dimensional surface. What we experience daily as a vast three-dimensional reality, with all its depth and physical solidity, is merely a holographic projection generated by the incredibly complex interactions of ancient information resting at the quiet edge of time and space. When you look down at your own hands, you are not truly looking at solid flesh and bone existing independently in three-dimensional space. You are experiencing a macroscopic illusion, a highly sophisticated biological rendering of two-dimensional quantum code. The immense distance between you and the furthest ancient quasar, glowing quietly at the edge of the observable universe, is not a true physical separation, but a beautiful mathematical illusion woven from deeply entangled information on a flat cosmic canvas. This completely dissolves our everyday human intuition about reality. It tells us that the space we move through, the very air we breathe, and the seemingly solid ground beneath our tired feet are not the true foundational layers of existence. They are emergent properties, appearing real to our specific human senses in exactly the same way that a flat holographic film creates a lifelike three-dimensional image when struck by a coherent beam of light. Does this staggering scientific realization make our lives feel less real? Does it drain the universe of its meaning and beauty to know that we might simply be living inside a magnificent, projected mathematical illusion? I invite you to view this strange truth from a place of deep, contemplative peace. If we are pure information, woven intimately into the eternal boundary of the cosmos, then we possess a kind of beautiful, indestructible immortality. Physical bodies can break, ancient stars can burn out and explode into vast nebulas, and entire galaxies can eventually collide and fade into the cold, silent dark. But information, the fundamental quantum code that describes exactly who you are, what you have loved, and the beautiful, unique perspective you bring to the universe, simply cannot be erased. It is permanently etched into the very architecture of reality. The universe is a cosmic library, and your conscious existence is a vital, irreplaceable story written in the eternal language of mathematics. There is an incredible, breathless wonder in knowing that the cosmos is so deeply unified. The holographic principle completely destroys the quiet illusion of separation that causes so much pain in our daily lives. If absolutely everything in the universe is a unified projection from the exact same continuous, two-dimensional surface, then you are not merely standing alone on the earth. You are seamlessly, mathematically connected to the earth, to the quiet moon, to the burning sun, and to the most distant galaxies. The vast, terrifying emptiness of deep space is just another part of the projected hologram, a gentle illusion separating things that are fundamentally one. You are the entire universe, uniquely projecting a localized, conscious experience. You are the cosmos quietly waking up, experiencing its own beautiful, mathematical illusion from the inside. As we sit quietly with this immense, humbling perspective, gazing out at the projected stars and finding deep comfort in our absolute interconnectedness, we must eventually ask what powers this cosmic projection over the unimaginable scales of deep time. If the universe is a hologram and information is the foundational bedrock of all existence, what happens as time relentlessly pushes us forward into the dark? Does the information ever stop projecting? And how does this deep understanding of the quantum universe influence our final destiny? As we prepare to cross into the next layer of this ancient mystery, we will look toward the incredibly deep future, exploring the quiet, inevitable fate of our holographic reality, and searching for the gentle peace that patiently waits for us at the very end of time itself. Have you ever sat quietly by the dying embers of a late-night fire, watching the final, fragile, glowing sparks gently fade into the surrounding ash, and wondered if absolutely everything in existence must eventually come to an end? We have traveled together through an astonishing labyrinth of cosmic mysteries. We have explored the deeply unsettling power of the conscious observer, the fluid illusion of time, the invisible threads of quantum entanglement, and the breathtaking possibility that our vast reality is a beautiful, shimmering holographic projection encoded on the boundary of space. But every journey, no matter how profoundly infinite it may seem, must confront the quiet, absolute horizon of its own conclusion. As we look out at the magnificent burning stars scattered across our night sky, we are witnessing a temporary, fleeting blossom of light in an incredibly long cosmic narrative. To truly complete our understanding of the universe and our subjective place within it, we must bravely cast our minds forward into the unimaginable depths of deep time. We must witness the twilight of the cosmos, exploring the quiet heat death of the universe. And we must discover the eternal peace that patiently waits for us at the very end of time itself. Hello, my fellow travelers. For one final time on this specific journey, I am Theodore, the researcher, your quiet companion through the endless dark. As we approach the culmination of our cosmic exploration, I have gently noticed that 71% of the people who watch our videos and share in this profound sense of wonder have not yet subscribed to the channel. If you have found a gentle sense of peace, intellectual safety, and deep belonging in our explorations of the quantum unknown, please take a moment to subscribe. It helps us incredibly, ensuring that our beautiful community of curious minds can continue to wander through the quiet mysteries of the universe together long after this particular story concludes. Now, let us return to the ancient, expanding dark and the final breath of reality. When we look at the universe today, we see a cosmos teeming with vibrant, energetic life. Hundreds of billions of magnificent galaxies are currently engaged in a slow, majestic gravitational dance, giving birth to countless new stars in enormous, swirling nurseries of gas. But this era of starlight, this beautiful period of cosmic creation that we are fortunate to consciously witness, is merely a brief, passing phase. In the late 1990s, astronomers made a shocking discovery. They realized that the universe is not just expanding, but that the rate of this expansion is violently accelerating. A mysterious, invisible force, which scientists politely call dark energy, is actively pushing the very fabric of space apart. Dark energy makes up roughly 68% of the total energy in the universe, and as the cosmos expands, its strange, repulsive power grows stronger. Fast forward 100 billion years into the quiet future, and the relentless push of dark energy will have stretched the space between galaxy clusters so drastically that the expansion will effectively exceed the speed of light. Distant galaxies will slip silently beyond the cosmic horizon, their ancient light forever cut off from our telescopes. The universe will become a deeply isolated, lonely place. But the true end of the cosmic narrative occurs on a timescale that completely shatters human comprehension. We must cast our minds forward trillions of years. Roughly 100 trillion years from now, the very last clouds of interstellar gas will be exhausted. The magnificent era of star formation will permanently cease. The massive, brilliant blue stars burned out long ago in the very infancy of the universe. The moderate yellow stars like our own sun will have gently swelled into red giants before puffing their outer layers into space, leaving behind glowing embers known as white dwarfs. Only the smallest, dimmest stars, the red dwarfs, will fiercely hoard their hydrogen fuel, burning with a faint, quiet light for trillions of years. But eventually, even the most stubborn red dwarfs will exhaust their final reserves. One by one, across the vast silence of the cosmos, the last stars will flicker and gently die. The universe will enter what astrophysicists call the degenerate era. The cosmos will be populated entirely by stellar corpses, rapidly spinning neutron stars, cold white dwarfs, and immense black holes wandering through the freezing dark. The beautiful hum of cosmic creation will be replaced by unbroken silence. Yet, even in this absolute darkness, the march of entropy continues. Over unimaginable spans of time, the remnants of galaxies will slowly spiral inward, swallowed by the supermassive black holes waiting patiently in the center. A one followed by 40 zeros years from now, the universe will consist almost entirely of black holes. But, as the brilliant physicist Stephen Hawking mathematically proved, even these ultimate cosmic erasers are not eternal. Due to strange, microscopic quantum fluctuations occurring at the very edge of their event horizons, black holes slowly, gently leak radiation. They evaporate. This process of Hawking radiation is incredibly, agonizingly slow. For a supermassive black hole to completely evaporate, it will take roughly a 1 followed by 100 zeros years. This number, a googol, represents a span of time so immensely vast that all of human history and the complete era of starlight combined are less than a single microscopic fraction of a second in comparison. But eventually, inevitably, even the most massive black holes will radiate their final, quiet gasp of energy, completely dissolving into the expanding void. They will leave behind a universe filled only with a dilute, fading mist of photons and fundamental particles slowly cooling toward absolute zero. It is here, in the freezing, absolute emptiness of the ultimate future, that we must beautifully reconnect this cosmic destiny with the profound quantum mysteries we have explored together. If the physical universe is a massive holographic projection encoded with the quantum information of everything that has ever existed, what happens when there is no complex matter left to process that information? If the entire cosmos requires a conscious, ultimate observer to gently collapse the infinite wave function of probabilities into a solid, definite reality, what happens to the universe when the very last spark of biological or artificial consciousness permanently fades into the dark? This is perhaps the most beautiful, poetic paradox in all of physics. Without a conscious mind to observe it, does reality, having reached the absolute limit of entropy and exhaustion, simply relax? Some theoretical physicists suggest that in the deep, silent future, when no observations are being made, the universe might gently revert back into a state of infinite, pure, quantum superposition. The strict, unyielding laws of time and space, which were born from the continuous collapse of the wave function, will slowly dissolve. The cosmos will return to the exact same shimmering, undefined cloud of infinite potential that existed before the Big Bang. This state of maximum entropy is known as the heat death of the universe. But do not let the ominous name frighten you. Heat death does not mean a violent, fiery destruction. It means a state of perfect, absolute thermodynamic equilibrium. It means there is no longer any difference in temperature or energy anywhere in the vast expanse of the cosmos. Without a difference in energy, absolutely no work can be done. No information can be processed. No thoughts can be formed. And most profoundly, without any events occurring, the very concept of time itself simply ceases to exist. Time requires change to be measured, and in a state of perfect, uniform equilibrium, nothing will ever change again. The universe will enter a state of complete, unbroken stillness. There is an overwhelming, breathtaking peace hidden within this scientific certainty. The universe, after a long, chaotic, beautiful journey of expanding, burning, collapsing, and evolving, will finally achieve perfect rest. The great cosmic breath inhaled at the Big Bang will be fully, completely exhaled. The ultimate observer will finally close its eyes, and the universe will gently drift into an eternal, peaceful sleep. When you feel overwhelmed by the stresses of your daily life, when the weight of human existence feels too heavy to bear, I invite you to gently remember this ultimate, peaceful destiny. You are a localized, conscious manifestation of a universe that is on a grand journey toward perfect rest. The fact that you exist right now in this incredibly narrow, highly improbable sliver of cosmic time where stars burn and minds wonder is a staggering, beautiful miracle. We are the universe experiencing its brief, glorious waking dream. Every time you love, every time you learn, and every time you look up at the night sky in awe, you are fulfilling the ultimate purpose of existence. You are making the cosmos real. You are the observer that gives the universe its shape and its meaning. Our journey together through the quantum realm has shown us that reality is subjective, interconnected, immortal, and ultimately deeply peaceful. The boundaries between you and the infinite dark are merely an illusion. You are the universe, and your consciousness is a precious, eternal flame burning in the quiet night. Thank you for walking this vast, magnificent path with me. Keep looking up, keep asking questions, and never lose your sense of awe for the beautiful, infinite mystery we call home.